Hello everyone, my name is Pengwen. I'm an 18 PhD student, and my advisor is Professor Hubert Pan. Today, I'd like to share our recent work with you. The title is To Cooperate or Not? Product Upgrading Strategy in a Competitive Display Market. This work is joined with Hubert Pan and Bolli. Our work is mainly motivated by Tesla and Toyota. Tesla launched its first version of electric car, Roadster, in 2008. And since then, Tesla has become a well-known electric car manufacturer. After seeing its great success, Toyota also wants to release a new version of electric car in the market. They will become competitors. But interestingly, instead of competing each other to release a new version of product independently, they choose cooperation to research and develop a common component, electric battery. And in 2012, Tesla released Model S and Toyota releases RAV4 its market respectively. The other examples about cooperation between two competing firms in two periods include Google and HTC, Amazon and Microsoft, and so on. So a question occurs that when and why the two competing firms have incentive to cooperate to release a new version of product. To address this question, the state of this project is as follows. We consider an industry consists of an incumbent and an entrant competing in two periods. The incumbent chooses cooperation or not and decides the improvement efforts and the prices. The entrant includes the market at the second period and chooses to accept the cooperation or not. Then decides the improvement effort and the price. We assume the consumers are myopic. They will decide whether or not to buy in each period and which product to buy in period 2. One consumer only purchases one product. If he buys one product in period 1, he will not buy anything in period 2. We explore the following 3 interesting questions. Firstly, we will explore under what situations the two firms can benefit from the collaborative upgrading and when not. Secondly, we will explore also the impact of entrants' initial product quality on pricing, improvement effort, and profitability for the two firms. Thirdly, we will explore also the impact of the marginal competition intensified by cooperation on pricing, upgrading effort, and profitability for the two firms. It needs to notice that if the two competing firms choose cooperation, their products will become more similar, and the competition will be intensified. There are three streams of literature related to our work. Firstly, the first stream of literature is about product innovation and quality design. For example, Lobel in 2016 considers one firm's product upgrading strategy in a dynamic market. We consider a dynamic competition and cooperation decision between two competing firms. Secondly, collaboration between two competing firms. For example, Professor Pan in 2016. They found that two competing firms may benefit from cooperation. We consider a two-period game and the incumbent's strategic behavior confronted with an entrant. Thirdly, new firm entry problem. For example, Professor Pan in 2017. They found that the incumbent may take some measures to deter the entrant to enter the market. We consider the product improvement and the collaborative strategies. I will show you the mathematical model here. The incumbent will define firm I sells a product in two periods. Secondly, at the end of the first period, the entrant will define firm E, enters the market, and firm I decides cooperate with firm E or not to release a new version of product. If they choose no cooperation, they will decide the improved effort EJ independently and incurs the cost EJ squared. J is I or E. If they choose cooperation, they will decide the improved effort E jointly and incur a cost E squared. We assume they share the improved cost equally. And at the same time, the competition will be intensified because of cooperation. Firm I's product has an initial quality which is normalized to B1, and firm E's product has an initial quality lambda. Firm I decides PI1 in period 1, and the two firms decide PJ2 in period 2 simultaneously. We use the Hotelling model to capture the horizontal differentiation between firms. If they choose no cooperation, they will decide EI and EE independently, and the distance between firms is 1. If they choose cooperation, two places are different. First, the distance between the two firms will change from 1 to 1 minus alpha E, and they will decide a common improved effort E. Then we can easily obtain the market segmentation in a uniform distribution line. If they choose no cooperation, the distance is 1, and the demand of the incumbent in period 1 is DI1. In period 2, firm E enters the market, and their demands contain two paths. One is loyalty consumers, and the other is switchers. If they choose cooperation, the distance between them will change from 1 to 1 minus alpha E, and the logic of the others are same. Then we can obtain the profit functions in the two situations. For example, pi I2, which means the profit of the incumbent in period 2 is equal to the loyalty consumers plus the switchers and multiplied by Pi2 minus EI squared. It needs to notice that in cooperation situation, they will share the improvement cost equally. This is the game sequence. Firstly, firm I decides Pi1 and demand for period 1 is realized. At the beginning of the second period, firm E enters the market, and firm I decides to cooperate with firm E or not to release a new version of product. Firm I and firm E decide the improved effort E jointly, or decides the EJ independently. Finally, firm I and firm E will decide PJ2 simultaneously in period 2 as demand is realized. We will use the backward induction to derive the model. Given Pi1, we can easily obtain the profit functions of the two competing firms in period 2. And then firm I will choose Pi1 to maximize the profit in cooperation situation with the following two constraints. That means the profits of the two firms in cooperation situation is not less than those in non-cooperation situation. The equilibrium solution can be divided into three regions. In region 1, the two firms will choose cooperation and neither of the two constraints is binding. In region 2, if alpha is small and lambda is in a relatively high level, they will choose cooperation, but the constraint for the entrant is binding. In region 3, if alpha is large enough and lambda is very small or very high, they will choose no cooperation and no constraint is binding. Through sensitive analysis, we can obtain some interesting results when alpha increases, which means the competition will be intensified. One might imagine that the prices and cooperation level may decrease, but in region 2, when alpha is relatively high, to elevate the competition, firm I may increase Pi1, and then there will be more switchers in period 2, which will encourage the two firms to increase prices and increase the improvement effort. And then the profit of the entrant may also increase. Secondly, when the initial quality of the entrance product increases, one might imagine that the prices of the incumbent may decrease. But interestingly, we find that in region 2, when lambda is in a relatively high level, the incumbent will choose to increase Pi1 and induce firm E to cooperate with him in period 2. Moreover, one might imagine that if lambda is increasing, pi E will also increase. But in this small region, we find that pi E decreases. It can be explained that if lambda is large enough, it will be not profitable for the incumbent to induce the entrant to cooperate with him. And then they will change from cooperation to non-cooperation. And both their profits will decrease. We can conclude two main managerial insights. Firstly, the two firms can obtain a win-win outcome from the cooperation only if the initial quality of the two products is similar. And secondly, if the entrance product initially has high quality, the incumbent can increase the price of the original version to induce the entrant to upgrade cooperatively. Thanks for your attention. Any questions?